Today on The Explainer, we're digging into the incredible forces that can make the very ground beneath our feet tremble and shake. Yep, we're talking about earthquakes.
You know, it's one of those fundamental questions, isn't it? We build our entire world on the idea that the ground is solid, that it's stable. So what in the world is powerful enough to suddenly shake it all up?
At its very core, an earthquake is all about energy. The best way to picture it is to imagine bending a stick. Right? You apply more and more pressure, and the stick stores that energy. But eventually, it hits a breaking point. It snaps. And all that stored up force is released in a sudden burst. Well, that's pretty much what an earthquake is, just on a planetary scale.
So, to figure this all out, scientists really had to become detectives. They weren't looking for a criminal, but for a cause. And the clues? Well, they were written all over the globe, literally, in stone. So, just like a detective sticking pins in a map, scientists started plotting the location of every single earthquake and volcanic eruption they knew about. The big question was, were these just random, chaotic events, or was there some kind of pattern hiding in plain sight? And when they mapped everything out, what they found was a total game changer. It turns out the quakes and eruptions weren't random at all, not even close. They formed these really clear lines across the globe, kind of like the seams on a baseball. This was a huge hint that there was some kind of hidden structure to our planet that we'd never seen before. So this pattern, it wasn't just a clue. It was a giant flashing arrow pointing to one single, really elegant theory that would completely revolutionize how we see our world. The prime suspect in this whole geological mystery was finally coming into focus.
And here it is. It's called the theory of plate tectonics. And honestly, this is the master key to understanding earthquakes. The theory suggests that our planet's hard outer shell, the lithosphere, isn't one solid piece. Instead, it's shattered into these massive moving pieces, almost like a cracked eggshell. And these are the heavyweights. We're talking about continent-sized slabs of rock. These enormous plates carry everything, our continents, our ocean floors, and they're drifting across the globe at about the same speed your fingernails grow. Just think about that. We are literally living our whole lives on these giant, moving rafts of rock.
Okay, so what could possibly be powerful enough to move something the size of a continent? Well, the engine is deep, deep below us, and it works a lot like a pot of boiling water on a stove. Hot material from the Earth's core rises up. When it gets near the top, it spreads out, pushing the plates above it. Then, as that material cools off, it sinks back down, only to get heated up and rise all over again. This constant, super slow-motion churning is called convection, and it's the force driving this whole thing.
Okay, so we've got these huge plates, right? And they're constantly moving, grinding past each other. But how does that super slow, steady movement turn into a sudden, violent earthquake?
It all comes down to pressure and release. See, the edges of these plates aren't smooth. They get snagged and locked together along cracks we call fault lines. And for years, sometimes for centuries, that pressure just builds and builds and builds until, boom, the rock just can't take it anymore. It slips, and all that stored up energy explodes outward as seismic waves. That's the shaking we feel as an earthquake.
So when scientists talk about an earthquake's location, you'll hear two key terms. First, there's the focus, sometimes called the hypocenter. That's the exact spot deep inside the Earth where the rock first breaks. Then you have the epicenter. That's the spot on the surface right above the focus, and that's usually where all the shaking feels the strongest.
Now this isn't just some cool science lesson. The theory of plate tectonics, it explains the actual world we live in. It tells us why some places are built on solid ground and why others are, well, a lot more restless.
And this is really the amazing part. This one single theory connects so many dots. It explains why earthquakes and volcanoes happen in those specific zones we saw on the map. It shows us how huge mountain ranges, like the Himalayas, were literally pushed up into the sky. It even answers that old question, why do South America and Africa look like two puzzle pieces that could just snap together? It's because they once connected. This theory proves that we live on a truly dynamic, active, and ever-changing world.
And that brings us to one last, really fascinating question. We've pretty much figured out the where and the why of earthquakes, but the when, that's still a mystery. It's a really humbling reminder that, for all we've learned, our restless Earth still keeps some of its biggest secrets.